Hey everyone, today we'll be reviewing for the Unit 7 test. So for 1 through 10, you have to use the diagram below to identify the object with the correct name. So it's matching, but in a different format. For the first one, we're taking a look at line segment GB. And notice that GB goes from the center to a point on the circle, so it's a radius. For number 2, if we take a look at it, we are given line segment AE, and notice that AE has endpoints on the circle, and it goes right through the center of the circle. So that is a diameter. And number 3, it's a little hard to see, but there are little arrows at the ends of that line segment. So we're looking at line DC in the picture. So I'm just going to highlight that really quick. And that's a line that goes through the circle and touches in 2 points, and that's a secant. Number 4 has little arrows at the ends too, so it's another line in our picture, and it's the line from F through H, and it only touches the circle at 1 point. That's referred to as a tangent. So just remember, tangent 1 point, secant 2 points. All right, for number 5, we're back to a line segment, no arrows on the ends, and we're looking at line segment FE, and that segment is right here. So it's a line segment, starts and ends on the circle. That's referred to as a chord. All right, moving on to arcs next. In number 6, we have just 2 letters, AB. The name kind of gives it away with just 2 letters. That's a minor arc. So minor arc, named with 2 letters automatically. All right, 7 and 8 are both named with 3 letters. So you might say that they're both major arcs, but you have to be a little bit careful. In number 7, it's arc ADF. So you want to trace that out using either your pencil or your finger. We want to go from A. We have to hit point D next, so we have to go clockwise around the circle, and then we have to end at F. And if you look at that, that is a huge arc. So it is a major arc. And just remember that major arcs are greater than 180 degrees. So we can cross major arc off the list. All right, the last arc we have is arc ABE. So we want to start at A, we want to go through B, and we want to end at E. And if you notice, the endpoints of that arc also happen to be the endpoints of a diameter. That means that ABE is a semicircle. So semicircle. And that means that it's exactly equal to 180. All right, number 9 and number 10, we're left with our 2 angles. And we have central angle, inscribed angle. So number 9, it says angle AGB. So again, trace it out. I'm going to go from A, so I use the highlighter here, from A into G, and then out to B. Notice that the vertex of that angle is at the center of the circle. That is definitely a central angle. Again, vertex at center. All right, the other one, well, hopefully it's an inscribed angle. That's all we have left here. So if we trace it out, it is going to go from A to E to F. So A to E, and then out here to F. That's this angle right here. And its vertex is on the circle. The endpoints of the angle are on the circle. It is definitely an inscribed angle. And we're going to come back to central angles and inscribed angles in a second as we talk about different types of problems to solve. Okay, in the second part, we have to find the measures of each indicated arc. But before we get started, notice that it says that I, K, and HL are diameters. And I'm just going to highlight one of those in here. Let's go for IK. So if that's a diameter, then we know that we have semicircles, 180 degrees. So just keep that in mind. All right, so right away, I see this 154. So I'm going to find this angle right next to it. So take 180 minus 154, and we're left with 26 degrees. So this little angle is 26 degrees. Those are central angles, so their arcs have to have that exact same measure. So I'm going to bring these numbers right out onto the arcs. Now, if you look at this notation, this arc is marked congruent to this arc, so bring the 77 degrees over to this. Now there's only one unmarked arc in here, unlabeled arc right here, and we can find that by taking the 77 and the 77, adding them up and subtracting from 180, or noticing that these two are vertical angles, so they're congruent. So that has to be 26 degrees, this has to be 26. Okay, so now we're ready to find all of our measures, and we're going to start with arc JK. So JK right here is 77 degrees. It's already labeled for us. It's a minor arc, so we'll just take the measure right from the diagram. HK, also a minor arc because we have two letters there. It's a little bigger, so we're going to have to go from H through J all the way to K. So we're going to be adding 77 plus 77, and we get a total of 154 degrees. If we go from I through J to K, I through J to K is our semicircle, so it's going to be 180 degrees. Okay, from J through L to I, a little different. So I'm going to choose the highlighter here. I'm going to choose red. Nope, there's red. Okay, from J, we want to hit L next, and then go all the way to I. So we're going all the way around the circle this way. You can just grab your calculator and add those arcs up as you go, but I'm going to write them out here. We pass through 77 degrees plus 26 degrees plus 154. A quicker way to do it would be to take 180 plus 77. No matter which way you do it, your total should be 257 degrees. Okay, I'm going to pick another color for the next arc. We're going from I through J to H. So I through J all the way to H. Okay, so that way didn't work. So I want to come back and we want to go the opposite way. All right, so you want to go with I. I'm going to choose a different color in here, maybe yellow. Go with I. You want to hit J next before you hit the H. And I just want to point something out to you. You can certainly do this by doing a lot of addition. You can do 154 plus the 26 plus 77 plus 77 going around the circle. Or the simple way to do it is to take 360, that's the sum of all the arcs, and subtract the one you didn't use, which was 26. So either add them all up or take 360 minus 26, but either way, you should get 334 degrees. And that's your final answer for that one. Okay, finally, we're going to end on a real quick one. KL, minor arc, right here, 26 degrees. And that's it. All right, you guys, in 17 and 18, we're finding the arc length and the area of a sector. So a little refresher on the formulas for arc length. The formula is you take your angle measure, divide it by 360, and multiply by the circumference of the circle, 2 pi r. So the angle measure in this case is 60 degrees. That's a match for the measure of the arc. So we're going to find out how long this arc is from M to N. So we take our angle 60 divided by 360 and multiply by 2 times pi times the radius, which is 15. 60 over 360 reduces to 1/6. 2 times pi times 15 is 30 pi. And then we want to multiply those. That would give you 30 pi over 6, which can be reduced to 5 pi. Now we need a unit of measure, so check out the radius. It's in centimeters, and we're going to leave ours in centimeters too. And this is exact form. And that's how I would like your answers written, okay? Do not multiply the 5 by pi by 3.14 or even the pi key on your calculator. All right, area of a sector is where we find the area of a piece of the area of the circle, like the area of like a slice of pizza, for example. So the formula for area of a sector is your angle divided by 360, because again, that tells you what fraction of the circle you're working with. But now we're going to multiply by area, pi r squared. So we're still going to start with 60 over 360, but now we multiply by pi times 15 squared. 60 over 360 is 1/6. 15 squared is 225 pi. Now, this one doesn't simplify as nicely as the last one did. We have 225 pi over 6. And while we can reduce it a little bit, we can divide by 3 in the numerator and denominator. It's still going to give us 75 pi over 2. If you wanted to, you could write this as 37.5 pi centimeters squared. And that's still an exact answer. There's no approximating. We do see a decimal, but it's a terminating decimal. It ends after the 5, so it's okay to have a decimal in front of pi. Okay, in 19 and 20, we're working with inscribed angles. And just a little reminder, the measure of an inscribed angle equals 1/2 of its intercepted arc. And that means that you can also work the other way and say 2 times the inscribed angle So 2 times your inscribed angle is equal to the arc. All right, so 2 different ways of looking at it. In number 19, we have this angle marked with 3x. It's inscribed, so we have an inscribed angle, and it's going to be equal to 1/2 of its intercepted arc. Well, the intercepted arc is labeled as 132 degrees. So you get 3x is equal to 1/2 of 132. Half of 132 is equal to 66. And then take and divide by 3. So 66 divided by 3 gives us 22. So x equals 22. All right, on number 20, it's a little bit more involved. So first, I want you to notice that we have 2 chords that are marked congruent. That means their arcs are congruent to each other. So we want to label this arc with an x. All right, in order to solve for x, we're going to have to find this arc right here, because the sum of x and that question mark would be equal to 360 degrees. Okay, so remember that this angle equals half of the arc. So to go from the angle to the arc, you're going to multiply by 2 or double it. So 2 times 54 is 108. So down here, we want to fill in this blank with a 108. So here's our equation. 2x plus 108 equals 360. Take and subtract 108 from both sides. And we've got 2x is equal to 252. Take and divide that by 2. And we get x is equal to 126 degrees. And that's our final answer. All right, and number 21, the theorem that we're working with is the one that says in a quadrilateral inscribed inside of a circle, that just means all four vertices of the four-sided figure are on the circle, the opposite angles are supplementary. So 3x plus 75 will be equal to 180. And along the other diagonal, 4y plus y will be equal to 180. So I'm going to write those side by side. Okay, solve each of those equations. All right, so the first equation, we'll subtract 75 from both sides, and that'll give us 105. So we have 3x is equal to 105, and then take and divide by 3. And 105 divided by 3 gives us x, and that's equal to 35. Okay, in the second equation, we have 4y plus y equals 180. So 4y plus y is 5y. And then take and divide both sides by 5. And this one gives us y is equal to 36. All right, that's it. Opposite angles of a quadrilateral inscribed inside of a circle are supplementary. Okay, for the last three problems, we're going to be writing the equation of a circle, or working with an equation of a circle. So it says write the equation of a circle with a center at -5, 8 and a radius of 11. So just remember that when we write the equation of a circle, we want it to be in standard form. So it's x minus h quantities squared plus y minus k quantities squared equals the radius squared. So the center is h comma k, and the radius, obviously, is 11 in this one. So we're going to write it first as x minus a -5 quantities squared plus y minus 8 quantities squared equals 11 squared. So if we're subtracting a negative, that goes to addition. That just becomes x plus 5, so you need to simplify. Don't forget, though, that it's quantity squared. Without squaring it, it won't be a circle anymore. It'll be a different type of graph. Right? With the y's, we can leave that as y minus 8 quantity squared, but I would like you to square the 11 and write it as 121. So this is the equation of our circle with a center at -5, 8 and a radius of 11. Number 23, I'm giving you an equation of a circle, and I'm asking you to identify the center and radius and then graph it. So remember that in standard form, this is x minus h quantities squared plus y minus k quantities squared equals the radius squared. Our center is at h comma k. The key here is that you have to take the opposite of the signs. So the opposite of +1 for the x would be -1. The opposite of -2 for y would be +2. So our center is at -1, +2. Right, on the right-hand side, if you look right here, that's our radius squared. So r squared equals 4. Take the square root, and we end up with r equals 2. Okay, as far as graphing goes, when you start from your center, you want to go 2 squares or 2 units in every direction. So go 2 to the right and put a point, come back to center, go 2 up, put a point, come back to center, 2 to the left, back to center, 2 down, and those will be 4 points on your circle. So connect the dots as smoothly as you can to create a circle. Not too bad. And that's it. Okay, so on to the last one. And it says write the equation of the circle in standard form, then identify the center and the radius. So your first goal, my friends, is to give me an equation in this form. X minus h quantities squared plus y minus k quantities squared equals the radius squared. Right, so the process that we go through is completing the square. So we're going to have x squared plus 4x plus blank plus y squared plus 6y plus blank. equals 12 plus those two blanks. Okay, so when you're filling in the blanks here for x, you're going to add that number to this side. When you're filling in the blank for y right here, you're going to add that number to the other side. Okay, so I'm going to group these together. The process for filling the blank in is this. Take this middle number, that 4, and you're going to divide it by 2 and square that result. 4 divided by 2 is 2, and 2 squared is 4. So add 4 to both sides. Okay, with the y's, you are going to take this number that's in front of y, and you're going to divide it by 2 and square that result. 6 divided by 2 gives me 3. 3 squared is equal to 9. And take and add 9 to both sides. Just going to add some parentheses here to group all the y's together. Okay, we're going to start factoring now. So factoring means that we want to break it down into 2 sets of parentheses. 2 sets for the x's and 2 sets for the y's. Over on the right hand side, go ahead and take all of these numbers and add them together. And 12 plus 4 is 16. 16 plus 9 is equal to 25. Okay, factoring the x's, start each set of parentheses off with an x, and then remember my tip. If you look at this number right before you squared it, that's what's going to go into each set of parentheses. It's a positive 2, so I'm going to write plus 2 in both. Okay. If you look at your y's, start each off with a y, and then whatever this number is, you're going to put that into each set of parentheses. And it's a positive 3, so we're going to write plus 3, plus 3. Now we almost have this in standard form. You have to condense your parentheses, so you have x plus 2, quantity squared, plus y plus 3, quantity squared, equals 25. Okay, I want to see that equation first, and then I want you to identify the center and the radius. The center would be -2, -3, because we have to take the opposite of positive 2, the opposite of positive 3. The radius is going to be 5. And we could have found that a long time ago because we had this number on the right-hand side. Remember that that's our radius squared. So then we're going to take the square root of 25, and that's going to be 5. All right, as always, let me know if you need some extra help. We can set something up and be ready for your test.